So we're looking at worksheet 3, which is orbital diagrams, electron configuration, and the relationship to the periodic table. So there's two new things on here that you haven't seen before, which is electron configuration and the relationship to the periodic table. So that off-ball chart we made earlier with the 1s2, 2s2, that I told you would make sense later with the periodic table. So we're going to look at the connection to the periodic table, but first we're going to start and talk about what electron configuration is. If you still don't understand orbital diagrams or valence electrons, I'd recommend you go back to those older videos and take a look at them. So let's start with the basics. Let's just do some random problems here. So atomic number is 3. What I do is I look at the periodic table. Lithium has 3. So here I would put Li, okay, and then I do the orbital diagram for 3 electrons. So we start with 1s, okay, and I'm going to need both electrons, so it's 1s2, and then I still need one more electron, so I'm going to go to the next sublevel, and I need 1 electron there, so 2s1. So all electron configuration is instead of having to draw these arrows, all we do is write what's underneath here. 1s1 and 1s2 and 2s1. And I'm not writing things right. Okay. And with an electron configuration, you can tell, or you could check yourself if you did it right by just adding up your exponents. So I get 3, which is the number of electrons. So I've done it correctly. Next, you're being asked valence electrons. Remember, valence electrons are find your highest energy level, which in this case it's 2, and you look at the S and P. So there's no P here, there's just an S, which has 1 electron. So our valence electron number is 1. Okay, so number of electrons in the outer shell. So let's do a slightly harder one. Let's do number 10. Actually, let's do number 9. So number 9, if I look at the periodic table, is fluorine. So I put the symbol F. I start with 1s. That's 1s2. 2s. 2. And then I'm going to write 2p. I'm at 4, so I need 5, 6, 7, 8, 9. Okay, so I used up 1, 2, 3, 4, 5 electrons here. So electron configuration, we're just writing the bottom. 1s2, 2s2, 2p5. And for some people, if electron configuration is easier for you, you can do electron configuration and then do orbital diagram. Valence electrons, we look at our highest energy level, which is 2. We combine the S and P electrons, so S has 2 and P has 5, so that's 7. Okay, so now I think you can kind of get a hang of this idea. You're just taking the orbital diagram and you're writing the bottom portion for the electron configuration. So I told you there's 2 parts to this worksheet. The second part of this worksheet, if you flip it over, you're going to see this. And what this is making you do is recognize a pattern between the periodic table and the information we were pulling. Orbital diagrams, electron configuration, and valence electrons. So what you're going to do in this table is you're just going to copy the periodic table. Hydrogen, lithium, sodium, sorry, I have a bad cough. Beryllium, magnesium, and you'll continue on with boron, carbon, nitrogen, oxygen, fluorine, neon, aluminum, silicon, phosphorus, sulfur, chlorine, argon, and this is for helium. What this is for you to recognize is you can tell the electron fit configuration from the energy level in the column that an element is, it will tell you the last thing you write in an electron configuration. So for hydrogen, it's 1s1 is the electron configuration. And if we go back to lithium, this would say the last thing we write in the electron configuration is 2s1. And if we look at our electron configuration from earlier, we have 2s1. Same thing with fluorine. The last thing we wrote for fluorine was 2p5. So 2p5. Now, knowing this, we can go back here and I can do number 17, which is chlorine. And I'm going to go to the periodic table and go to chlorine and go with that. Know that the last thing I'm going to write is 3. So 3 is the row it's on. That's the energy level. 3p5. So what I can do is I can write 3p5 here, and I can work my way backwards. So 3s2, 2p6, 2s2, and 1s2. And if I do the math, 2 plus 2 plus 6 plus 2 plus 5 is 17. So it helps me do this and just check my steps. And we'll label your actual periodic table in a second. The other thing this is giving you is the number of valence electrons. So depending upon your column, the top of the column will tell you how many valence electrons you have. So everyone in the first column has 1. Everyone in the second column, including helium. So helium is actually on this side, but in terms of valence electrons, it goes here. So it has 2. Now the next part we skipped to was this side. Here you actually have to write out the electron configuration to figure out the number of valence electrons. It varies, but for these, the valence electrons are going to stay the same. So for the P's, 3, 4, 5, 6, 7, and 8. So if we look at this on your periodic table and you're actually going to label this, okay, so you can write the same thing. This is your S1 section. This is your S2. This is your P1, P2, P3, P4, P5, and P6. Your valence electrons for these columns. And I think I need to zoom out a little more. Is 1 valence electron, 2, 3, 4, 5, 6, 7, 8. You may want to make a note for yourself that helium is just 2. And then your energy levels are 1, 2, 3, 4, 5, 6, 7. This whole first section is the s orbital. So everything in here ends with the s sublevel. Everything in this section is known as a d. Everything down here is an F. Let me just put it up here. And everything in these sections right here is a P. So what you can do is you can take an element and you can walk your through way to this section. So if I want to do scandium, that's 1s2. Remember, helium goes right here. And then 2s2, 2p6, 3s2, 3p6, 4s2, and then here is a D. Now, There's something weird with the D's and F's. Their energy levels are one more. So 3, 4, 5, and 6. If you remember your off-ball chart, when you were doing your off-ball chart, and you did 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 4, 5, 6, 7, S's, P's, D's, and F's. So you'll notice with this chart, after 4S comes 3D. So if you look here, after 4S, we get into the 3Ds. Okay, so 3D1, 3D2. And the F's are peculiar too. The F's, so after 6S, you'll notice you go to 4F. So here you put a 4 and a 5 as your energy level. These two columns right here actually fit in right here. So if you got to 6S2, next you would go to your 4Fs, and then you would go into your 5Ds. So this is how the periodic table matches with your chart and how it can help you with electron configurations. If it's confusing to you, you can still use what you've been taught before.